From the smallest atom to the largest galaxy, the universe is in a constant state of motion and change. Physics is the science that seeks to understand the fundamental laws governing this grand cosmic dance. It's a quest to unravel the secrets of the universe, from the forces that shape galaxies to the particles that make up everything we know. At its core, physics is about asking fundamental questions. Why do objects fall to the ground? What is light, and how does it travel across vast distances of space? How do stars shine, and what are they made of? These questions might seem simple, but finding the answers has driven centuries of scientific inquiry. Physics is not just about understanding the universe, it's about using that understanding to improve our lives. From the technologies we rely on every day, like electricity, computers, and medical imaging, to the frontiers of scientific exploration, like space travel and renewable energy, physics plays a vital role in shaping our world. To understand the universe, we must first understand its basic ingredients: matter and energy. Matter is anything that takes up space and has mass. It's the stuff that makes up stars, planets, and even us. Energy, on the other hand, is the ability to do work. It's what makes things move, change, and transform. One of the most fundamental concepts in physics is motion, the change in an object's position over time. Sir Isaac Newton revolutionized our understanding of motion with his 3 laws of motion. These laws describe how forces interact with objects to produce motion. His first law, the law of inertia, states that an object at rest will remain at rest, and an object in motion will stay in motion at the same speed and in the same direction unless acted upon by an unbalanced force. Newton's second law tells us that the force acting on an object is equal to its mass times its acceleration. This equation is fundamental to understanding how objects move under the influence of forces. Finally, Newton's third law states that for every action, there is an equal and opposite reaction. This means that whenever one object exerts a force on a second object, the second object exerts an equal and opposite force back on the first. The universe is a symphony of waves. From the sound waves that vibrate our eardrums to the light waves that illuminate our world, waves carry energy and information across vast distances. In physics, a wave is a disturbance that travels through space and time, often transferring energy without transferring matter. Light is a particularly fascinating type of wave, an electromagnetic wave. Electromagnetic waves are disturbances that travel through the electromagnetic field, which is a fundamental force of nature that describes the interactions between charged particles. These waves travel at the speed of light, which is approximately 299,792,458 meters per second, the fastest speed anything can travel in the universe. Electricity and magnetism, once thought to be separate forces, are actually intimately connected. They are 2 sides of the same coin, known as electromagnetism. Moving electric charges create magnetic fields, and changing magnetic fields create electric currents. This fundamental relationship is the basis for many technologies, including generators that produce electricity, and motors that power everything from electric cars to household appliances. While classical physics, as described by Newton and his contemporaries, provides a remarkably accurate description of the universe at everyday scales, it breaks down at the subatomic level and at extremely high speeds. In the early 20th century, physicists developed 2 revolutionary theories that extended our understanding of the universe: quantum mechanics and Einstein's theories of relativity. Quantum mechanics delves into the bizarre world of atoms and subatomic particles. In the quantum realm, energy, momentum, angular momentum, and other quantities are quantized, meaning they can only exist in discrete values. This is often phrased as quantumness. Furthermore, particles can behave like waves, and waves can behave like particles, a concept known as wave-particle duality. Einstein's theory of special relativity, published in 1905, revolutionized our understanding of space and time. It postulates that the laws of physics are the same for all observers in uniform motion, and that the speed of light in a vacuum is the same for all observers, regardless of the motion of the light source. One of its consequences is that space and time are not absolute but are relative to the observer's frame of reference. Einstein's theory of general relativity, published in 1915, extended special relativity to include gravity, describing gravity not as a force but as a curvature of space-time caused by the presence of mass and energy.